All right, so the Eisenhower Star, how I do it. So first right off the bat, what I would do is pick a star. I just randomly made this with Corel, but what we need to avoid is having certain like different versions of measurements. Some of them just called out by number, and others that actually will exist once they're routed. The problem is like the angle here. So like giving me a PDF that says this is 11 and this is 18 means that you're going to get a different angle here than you are the actual star that's drawn. So first and foremost, what I would do is get the star that we want on the ground, um, like dialed to size, and then that would be the master template. And then literally that will become the master template, in that what I would do at that point is then pick your 11 inches across and go ahead and lop it off there, and that will become our point. And if that's, 18.10 or 18.024 or whatever it is, but we know that we're working off of this. Going forward, from there, I would go ahead and do the expense and labor of routing out these 5 pieces and being able to bolt together a master template out of metal, nice and sturdy. And that way we'll also have translated the holes on the corners. But also that means that if you're going to bring in a subcontractor to cut, the star out, we're not just giving him measurements and then they kind of do their own sort of version of a star, and then it's bad news. So because they could get these points off. This could be a little wider, change this angle, and then our pie slices don't fit. Our obelisks. Yeah, I'm looking at you. So I would start there, and then from everything, like, if we have to make a couple of these, whatever, but you could bolt this together. You could send this to, if this is supposed to be inlaid marble or something or whatever, but I would work with a real deal thing there. And that way, we're all literally on the same page, and not just try to shoot measurements to people through a PDF or something and have something go wrong. Yeah, and then like I say, when it goes time for us to install this, uh, even if this is like an inlaid piece of granite, or I don't know what that is, this could maybe be sent to the granite people, and they could even drill the holes for us to make sure it's we don't actually accidentally break it or something. So this could have several uses. So I would budget in some, real world templating, in 090. So from there, I took this piece, I took the little plinth, and I put it into my mine palace, and I took it into the fabrication department there, and I have access to all sorts of brakes and presses and things like that, and tried to build this thing the best way I could see how. Like you talked about, we do 1/8 inch, and we'd have the 2 faces. So I was trying to figure out how to keep this continuous. Um, so doing it the way we do, where we bend and scribe, really wouldn't work, because you have to clamp it up to one side, like let's say the blue side here, and then you'd have to bend it. So that means that it would just go flat across here, and then you'd have to make a really big groove, and then really it wouldn't be pretty, because then this piece would be down here. And so we're not obviously not going to a knife point, but that's what I'm trying to figure out, is like, so our pinch and bend method really is only good to a degree, pun intended. It doesn't really work anything over 90 too much. You can usually fudge it, but once you start doing this, you start losing the accuracy of any sort of clecos that you have to line up and things like that, because it becomes really funky. So you could, like I say, you can imagine what that would look like. So then I'm like, well, if we go ahead and just do a groove in the middle and try to do an equilateral, symmetrical bend, and just bend it and fold it, that could be done. Definitely not going to work just on the table, because again, it's going to kind of bend in a weird way, and it could go flat and then make this piece go long. So this piece ends up out here. There's all kinds of nightmare scenarios there. So I was thinking, well, you could throw it in a press brake, like we have done with Palm Springs Welding. They have a press brake, and yes, you could put that in the V groove of a press brake, bring it down. I have been there. We've done it a couple times, and I didn't really have much confidence when they did it before. Thankfully, we were just doing some 1/4 inch brackets that really didn't matter that much, and I gave them a little line to hit, and they hit it okay. So whoever it is that's going to do it for us, or one of the times James went over there and they said, hey, you know how to use that thing. So James did it himself, but that's fine. But now you're an inexperienced operator trying to get this thing to, a several ton press, come down and try to get this nice. If this is a little bit off, a little bit crooked, then obviously these guys here won't line up and it'll kind of be cocked. So we will have to get these guys water jetted, and I'm just assuming it's RNS. So I kind of exhausted several options of what would be the best order of that, because we're going to have to route stud weld patterns for the backed up either Corian or acrylic that we use for the stars. So one of the ways would be to just, send them a file. They could pull a sheet of eighth, and then using a file we might send them can index where the stars are on that sheet, give us the sheet, we could route it out. Or opposite that, go backwards, where we go ahead and route out our pieces and then send them to there and then bring them back, and that'll work too. They can just index each rectangle, on their water jet and do the stars. I think that would be the way to do it, is we route everything first. That being said, so what I was saying is trying to keep this as one piece also has that issue of, like, we route these out, we have the stud welds, we have I'm going to be putting a groove here, so there's going to be some things we need to set up, and we send those over there, get those water jetted, and then they come back, and then if we goof up the bend, that's a lot of investment that has to be redone and back down to Redlands, or Riverside. So that's why I'm thinking that we go ahead and just bite the bullet, and we are just going to route each panel individually, and just have separate panels, and then have separate pie pieces for the top and separate pie pieces for the bottom. We'll go over that. So I think that would be the best option. It eliminates having to bend this and get this right. We do have to deal with the fact that the two pieces of metal will just meet up and we'll have this. So whether or not that can just be sort of bondoed close, or we just live with it, that's fine. Or we just give it a little bit of round and just kind of sand it down a little bit, so it's just sort of kind of nice. So, but I think that is the option we'll go with. So that way, what we can do is route each individual rectangle and then set it up, and we could even on the inside put A, B, C, D, whatever, and then send those files to RNS with a palette of these guys, and then they can just reference them, because the stars don't have to be perfect exactly where they need to be. They'll obviously be within probably a 30-second or something, but they can just register the rectangle on their table and then go from there, and then send them back to us. That way there's no risk really of us messing up unless we do something very bad or something, or we drive over it or something. So that way we don't have to have that kind of roll the dice kind of action with having all that investment in time already. So once we have these pieces separately, though, we're back to the early times of Mingo and myself just trying to hold things together square. And as you can see, you've got this pie shape. So you put one side down on the ground, on the table, and then you're trying to make sure this is square, and you're trying to line up all these corners and stuff. Unfortunately, because we're not going to be able to bend this and use any sort of the benefits of doing the bend method, where all the accuracy is inherent in the piece that you bend, and you have the CNC working for you. So in order to make the CNC and still use the bendy method, then you take the bendy method and you put it into a jig. So I think we will invest the time and the money to do a jig that will help us put all 5 of these in and get everything lined up really nice. And give us a really good fighting chance at making these look nice, because we are going to have that reverse channel letter problem. So we are going to have to stitch it. We're going to have bumps. Things are going to warp. There's even a chance that as you tack this along, this could katana a little bit because the heat's going to pull it. So not super visible, but we're going to have that issue because we are spoiled with having everything bent and accurate and lordsed and tacked in such a way that nothing really distorts that bad anymore, and everything lines up almost perfectly. Whereas we will have the old school issues of trying to get this corner lined up and that corner might be a little out. So to have a nice setup like that, it will be worth it. So similar to the Living Desert ID signs, I told Johnny that maybe the jig is just worth one more sign, so if we're doing 30 signs, maybe budget in, another whole sign. This would just be out of 090, riveted together, very simple, rather quick, but it'll be nice and accurate. Showing this, we'll be able to drop the two faces in, and we'll provision a way for these to match up just right. And then you can double check that everything's all on the level. And then we'll go over this, but this will be the face plate. That'll drop into the groove. We'll have access to that. And then we can just make sure everything's really nice and sexy. We'll be able to put the end cap in nice, and that'll make sure that's in. And then we'll be able to make sure the bottom end cap is in. And so that'll just bonk up against those ends. So it'd be a nice little cradle. And then this would be the seam looking down on it right here. So you'd be able to just access that seam, kind of jump around, and the spars here would sort of keep everything nice. You can take and then maybe route a piece that would act like a pressure plate that you could kind of wedge in there and force it to stay up against these spars here. So I think you get the idea. That would be worth it to make that investment, make one of these, and then that way it turns it into a slam dunk. So the internals, how I see the internals here, we'll have the top will just be smooth, just welded along. We'll have to have some sort of a face frame. So learning what I learned with Morningside and doing these Palm Springs Art Museum, things like that, the minimum is 3/8 right here. If we're doing a 1/2 inch thick anything more, you will start to get a little shadow. So we'll have to keep this as thin as possible, and it's going to be kind of tough, but this will be a perimeter ring that gets routed out. Looking at it from the top here, you can see that's that 3/8 ring all the way around. So that'll be on the front. We'll have to weld it from the front. So that's what this little guy's here. We'll have to weld it from the front because there's no access from the back. And then we will have to provision the acrylic accordingly, but still leave enough so we can, inject the silicone and it stays. So, and then we're just gonna have to silicone this in here. So access is a problem at that point because we don't want to have to be cutting this in and out to get in. So I'm proposing that yes, we will have to have some screws at the bottom, but this makes it more simple to install, slam dunk. I know that it's try to do a countersunk screw, try to hide it, et cetera, et cetera. For structural mounting, there's no such thing as a counter screw that's going to tighten down properly. There just isn't. It doesn't matter how careful you are with the countersink, all that. There's a reason why there aren't countersunk bolts on a bridge. There's nothing is countersunk when it comes to actual structural rigidity. So I would go with these guys here. They're not that big. You'll have the hex as sort of a little bit of security because not everyone's walking around with a 5/32 hex bolt, and the head is just very minimal, nice flat low profile, and so that's that to scale there. So what we would do is just have a base plate in black. That would be the internal pie piece here. That's what we would nail down to the ground, provision power coming in, and then the purple here and the blue connect inside the sign. And that creates a light block, but you can see where the blue comes down and gets bent. That gives it rigidity at the base where the acrylic comes right to the ground, and then we can tack it to the purple piece, and then that will make a nice little floor for light leak. And then we have a raised cavity pocket that the thing will slide over the black piece. We'll have riv nuts ready, and then basically that's what we're looking at there is just a nice little black black it out or bronze it out, whatever. The thing is you'll be standing on the inside of this, so it's not like you'll be looking at these directly. You'll be kind of in the middle, sort of walking around. You visually won't even really see them that much, so it'll just be part of what it is. It's fine, But I think that would be our strongest bolt down method. That'll hopefully get us some strength to put up with people wanting to sit on these like idiots, or really wanting to lean on them or whatever. So I think this would be the best way to bolt these down. That gives us serviceability. And then as far as lighting is concerned, I have drawn here, I understand maybe it's an ascension thing that you were talking about where it kind of glows up. My knee-jerk automatic response is that we need to have full, nice light, across the face, nice and bright. So, but I understand, yeah, it might not be it. We could modify this in different ways. possible. So this is just some bent up 063, you know, routed out, make a little system. We could just rivet it together. So this allows for long lengths of just our, you know, GE product, and that'll give a nice wash. It's good enough for the stars back here, and this should give a fighting chance to kind of evenly light this face all the way up. So we could go with a combination of this. I know you're talking about maybe doing a fixture from the bottom, but it for sure will not light this. You know, it'll definitely be a bright, 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 less bright all the way up. I understand the stars as well. You might be looking for something where it's brighter down here and less there. We could also do a combination of that where we could light the face with these and then do a puck, one of those cabinet lighting pucks that's good for, you know, some of them are good for 48 inches, but some of them are good for 24 or 30. At least it'll be bright. It'll give that sort of ascension glow. So we could mix and match. You could attach that puck down here. And then, you know, these forward facing ones could kind of take care of that. What I would do is budget in time for that experiment later on, you know, so once this thing's built, then we can, you know, in the shop we could try different things. But as you can see, the power supply would mount nice here. We could use one of those nice little Keystone small ones, and it could be towards the bottom down here. So this means nice and serviceable. So you can just undo these 4 screws, pop these off, get to whatever needs to be changed or whatever, and then bring this right back down, screw it down nice and tight, and should be nice and secure. So I think that should do it, just in summary. If you have any questions or whatever, just hit me up, let me know. But I think that's how I would do it. If you have any other questions or anything, or we'll go over the actual order of things or advice on that. So, but I think this gives you a good idea to work off of.